Hello, algebra scholars. This is section 6.6 on rational equations. As you can see here, we have a slightly longer algorithm, and this is a pretty involved section, drawing on a lot of previously learned knowledge. So you may find yourself flipping back in your notes to remember how to do a few of these things. Anyway, so we have a five-step algorithm. Step one is to list the restrictions, the numbers that make each denominator 0. We'll talk more about that. Find the LCD, and once you've found it, you're going to multiply every term by the LCD or by the LCD over 1. When you do that, you're going to get a first degree or a second degree equation. If you get a first degree equation, you'll solve it by putting the variables on the left and the constants on the right and dividing by the leading coefficient. If you get a second degree, you have to remember how to do the zero product property. And then finally, you need to check your solutions against any restrictions that you listed back in step 1. Okay, so the no LCD yet. Back it up. Restrictions on this problem. What can x not equal? If we say x were -2 and we tried plugging that in here or here, we would get 0 on those denominators, and you cannot divide by 0 in math. So we have a restriction which says x cannot equal -2. The LCD for this problem, I hope is clear, is x plus 2. So that's the first two steps. We're now going to multiply every term by the LCD. Even this first term, which is just the number 1, it gets multiplied by the LCD. And then the second term gets multiplied by the LCD over 1. And the third term gets multiplied by the LCD over 1. Okay, so this first bubble simplifies to x plus 2. The second bubble simplifies to 3x. And the third bubble simplifies to -6. We see we have a first degree equation. So we're going to get our variables all together here. 4x plus 2 equals -6. We'll subtract 2 from both sides. 4x equals -8. We will then divide by 4 and say x equals -2. But wait, we had a restriction at the beginning of this problem that said x cannot be -2. And here we are trying to say that it is -2, but it cannot be. So this problem actually has no solution. All right, algebra scholars, here is a second example, and I've copied our rules over so we have them to look at. So step 1 is to list any restrictions, and we see that if x were 1, we'd have division by 0, so x cannot be 1. The LCD is also pretty clear. I think it's x minus 1. Hope you all see that. So we're going to multiply every term by the LCD over 1. And here, the x minus 1's cancel, and we're left with x squared. Here, the x minus 1's cancel, and we're left with 1. Now, what we have here is a second degree equation, and we need to solve it using zero product property, which means we need to get 0 on one side, and we can do that by subtracting 1, and we get a product by factoring. This is a difference of squares. And once we factored it, we set each factor equal to 0, and we solve each of these little mini equations. And we see that x equals 1 or x equals -1. But don't forget step 5 to check your solutions against your restrictions. Our restriction says x cannot be 1. So this cannot actually be a solution. So the only solution to this problem is x equals -1. All right, algebra scholars, here's a third and final example. To list the restrictions here, we actually need to do some factoring first. It's pretty clear that x can't be 2 from the first fraction, and it's pretty clear that x can't be -4 from the second fraction, but what about this third fraction? We're going to have to factor it to find out. So two numbers that multiply to negative 8 and add to 2, 4 and negative 2, so it factors into x plus 4, x minus 2, which were actually the two denominators from before. So the two numbers that we thought were restrictions turn out to be the only restrictions. X can't be 2 and x can't be negative 4. So it took a little work there to find the restrictions. But now that we've done that work, it's actually going to make finding the LCD easier. And hopefully we see that it is x minus 2 times x plus 4. So let's multiply every term by the LCD over 1. So there's the first term times the LCD. And now I'm going to multiply the second term by the LCD over 1. And I'm going to multiply the third term times the LCD over 1. Okay, and let's go back and circle our three terms here. X minus 2's cancel, and we're left with 2 times x plus 4. Here the x plus 4's cancel, and we're just left with an x minus 2. Here the x plus 4's and the x minus 2's cancel, and we are left with x. Now I'd like to clean this up a little bit here. What do we have? We have 2x plus 8 plus x minus 2 equals x. Looks like a first degree equation. So let's collect our terms together. 3x plus 6 equals x. I'm going to subtract x from both sides. 2x plus 6 equals 0. I'm going to subtract 6 from both sides. Get 2x equals negative 6. I'm going to divide by 2, and I'm going to get x equals negative 3. And we see that that does not violate either of our restrictions that we laid out at the beginning. So that is a good solution. We'll keep it. That's all. Good night. Goodbye.